This video is for August 17th, August 18th, what we did in class. The main goal today was to look at tangent and cotangent and be able to evaluate those two functions. But before we even started looking at tangent or cotangent, what we started looking at is sine and cosine. Now, if you have a unit circle, I would pause this, take that out, because we're going to need that to evaluate these functions. But maybe do the first four and then go to tangent and how we can define tangent. But here, if we want to find sine of negative 4 pi, then in class we discussed, well, negative 4 pi, if we found it on our unit circle, we could calculate that pretty quickly, but negative 4 pi is not on our unit circle. So we talked in class on how we could figure out where that fell. And what students said is, well, we can do coterminal angles. So we spent a lot of time in the past on last class on coterminal angles. And there's a lot of different ways we could do that. I'm going to go ahead and say, if it's in radians, add 2 pi. Maybe I do it one way here and another way for this one. If I add 2 pi, I get negative 2 pi. I still not on there. 2 pi, where's that coming from? That's all the way around the circle. So we're adding 2 pi to go all the way around the circle in the opposite way of the negatives. If I add another 2 pi, that would just be 0. Now this does fall on our unit circle. It's right there on the positive x-axis, like 0 and 2 pi. It's the same, coordinate. And because negative 4 pi is coterminal with 0, then what really is happening here is that sine of negative 4 pi is going to equal sine of 0. And if we look at 0, the coordinate pair there on our unit circle is 1, 0. Sine is always the y-coordinate, so sine of 0 or sine of negative 4 pi is just 0. So key concept here is that we need to find a coterminal angle with this angle here. If it does not fall in our unit circle, then we can locate it and figure out the sine or cosine value. All right. This is just one way by adding 2 pi or subtracting 2 pi if it were positive. Like in this case, that would give us that coterminal angle. So let's do this. So again, I look on the unit circle, 11 pi over 3. I don't see it. So another thing that people did, and I might need to get a calculator here. So we could subtract 2 pi. Let me go ahead and do that. So we could subtract 2 pi, but we need to be careful here. If we have fractions, we need to get a common denominator. So to make sure that we have a 3 in the denominator here, multiply that fraction by 3 over 3. So that would give us 11 minus 6 gives us 5. The 3 stays, so 5 pi over 3. So what we're really saying here is that cosine of 11 pi over 3, because 11 pi over 3 is coterminal with 5 pi over 3, the cosine values are going to be the exact same. Is 5 pi over 3 on our unit circle? Yes, it's in the 4th quadrant where 300 degrees is. And so we look there and we find that the x-coordinate is 1/2. And so your answer there is 1/2. So again, subtracting 2 pi, that could work. And I saw really the other calculating method is to multiply by 180 over pi. Or in other words, to convert. Let me make sure I'm doing this correctly with my handy dandy calculator, since I can't use my cell phone. So we do 11 times 180. That gives us 1980 pi over 3 pi. The pi's would cancel out. So we would do 1980 divided by 3 would give us 660 degrees. Now because 660 is bigger than 360, we can subtract the 360 to get to 300 degrees. And that falls in the same place as 5 pi over 3, which means that the value there would be 1/2. Both of these ways are very valid. By adding, if it's negative, adding 2 pi. If it's positive, subtracting 2 pi to get the coterminal angle. The only thing here is we need to make sure that we have a common denominator, or some students converted and then subtracted 360. Either way. Only thing is, I saw some students just like, oh, rock and roll. I get it. I'm going to subtract 2 pi. Well, let's pause. So here, if you look, always look and see if it's on the unit circle. Here, 7 pi over 4 is on the unit circle, so we don't need to find a coterminal. Only if it does not fall on our unit circle do we need to find a coterminal. But 7 pi over 4, that's in our fourth quadrant, so we can look there at the ordered pair, and the x value would be square root of 2 over 2. Okay. And you could do that for all of these. And we spent time in class doing this, finding the coterminal angle and then looking at the ordered pair. All right, I'm going to go to the back side. I think I can squeeze it in on this and then go through a calculation in the next video. So here, now what we try to do is to redefine tangent. And we started with the original definition, that tangent of theta, this is the angle theta. That's typically just a variable for angles. The original definition, if we're given a triangle, a right triangle, is opposite over adjacent. So we would look at the angle, take the opposite side divided by the adjacent to actually get the calculation for tangent, excuse me. But this would be annoying if we had to use this definition to calculate tangent every time. So what I suggested in class is, hey, what if we use sine divided by cosine? So I'm going to say tangent of theta is sine over cosine. If you need to pause, please feel free to do so. But we need to validate this. Can we validate that sine divided by cosine does actually get us back to tangent? And we can. What we did in class is said, let's write the division like this, sine, because over is really sine divided by cosine, so I could write sine divided by cosine. And then what we did is use the original definition. So here, sine, in terms of the original definition, it would be opposite over hypotenuse. And cosine would be adjacent over hypotenuse. If we're dividing fractions, this is a key piece. This is a very key piece that we talked about and I tried to hit home in class. In order to divide fractions, this first fraction stays the same. But to divide, you multiply, and this fraction we multiply by the reciprocal, or in other words, that fraction flips. So that's a key piece on multiplying or dividing fractions. You always multiply by the reciprocal, and it's always the second fraction that flips. Now we're multiplying two fractions. We can multiply straight across, so we would have opposite times hypotenuse over hypotenuse times adjacent. Just multiplying these two things and these two things. And what we can see here is that the hypotenuse cancels out with that hypotenuse, and we would be left with opposite over adjacent, which is what we wanted. So, as I said in class, I will not ask you to prove that tangent equals sine over cosine. It's not something I will not ask to reproduce this. But I did want to show this to actually show that tangent is sine over cosine. We can redefine tangent this way. And the way that works is because of this division. By multiplying by the reciprocal, the hypotenuses cancel out. We get opposite over adjacent, which is the original definition for tangent. Now, in the next video, we're going to see some examples of that. I'll probably do 2 of those, talk about this last one, and then we'll talk about cotangent as well.